when you're going to evaluate a logarithm by hand, it's a good idea to turn it into a small equation. For instance, log base 2 of 32 has to have some value. Looking at it as an equation means that I can rewrite it as an exponential equation. That's where we keep the base the same and switch the other two. So 2 to the v is equal to 32. And I want to figure out what v is. So I start going through my powers of 2. For instance, I know 2 squared is 4. And 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth is 32. Once I hit on this 2 to the fifth equals 32, then I know that this value has to be 5. So the thing to remember is that the value of a logarithm is the power. So thinking about log base 7 of 49, that means 7 to what power is 49? And that's obviously 7 squared is 49. For log base 5 of 125, well, one thing I notice is that 5 to the third power is 125. But I'm not trying to find the power that will make 125. I want to make 1 over 125. And what puts a value in the denominator is when the power is negative. So 5 to the negative third would be 1 over 125. So this logarithm is equal to negative 3. When we have log base 9 of 3, I know that the square root of 9 is 3. As a power, the square root is 1/2. So the log base 9 of 3 is going to be 1/2. Similarly, with 49 and 7, I know that the square root of 49 is 7. As a power, the square root is 1/2. So log base 49 of 7 is 1/2. When it comes to log base 4 of 2, well, let's see, I know the square root of 4 is 2, so that means 4 to the 1/2 is 2. But I have 2 in the denominator, so I have to take that 1/2 and make it negative in order to take the 2 and put it in the denominator. That means log base 4 of 1/2 is negative 1/2.